In this episode, I'm going to show you how to set up ida-cmake in order to build the plugins, processor modules, file loaders from the IDA SDK or any of your IDA projects with ease and convenience using CMake and IDA CMake scripts. So let's get started. The first thing we need is to have the SDK installed. As of now, that's the latest SDK. It's SDK for IDA 8.2. That's the first thing we need to do. Now, need to make sure we have CMake. Let me see if I have CMake real quick. CMake, I don't have it. You might need to download it. So real quick, we go to cmake.org and just grab the appropriate version for your operating system. Meanwhile, while CMake is installing, we can go to the ida-cmake project. We'll be linking that full URL as well and clone it. So I'm gonna just take a copy of that address and clone it. Now there are lots of instructions, but the quickest way is just to follow the quick start guide. And so for that, all I'm going to do is to go to that folder and open the command prompt in that folder and clone it here. So we should have IDA SDKs and the folder ida-cmake. So let's just paste this, git clone. That's the first step, getting this. And the second step is to set IDA SDK to point to where is the base of the SDK. This is not necessarily very productive. If we open another prompt, we won't have this environment variable. So if you're a Linux user, you will add this to your, let's say, bash.rc file and so on. On Windows, we'll add it to the environment variable. So in the system settings. So I'm gonna go here to start environment and search for environment, and we get it here. So here in the environment variables, we add a new environment variable, and I'm gonna copy the path of the SDK. So first, the variable name is gonna be IDA SDK, and the value is the location of the base of the SDK. Now, if you have a different SDK, there are ways with ida-cmake where we can build the same plugin with various different SDKs without having to change the environment variable. So we can point where the SDK is from the command line. But for now, the easiest way, simply set it up once and forget about it. So once we did this, now if I open a new prompt, if I start all over again, open a new prompt, command prompt, and then try to see if we have an IDA SDK. We do have an IDA SDK set up. So now let's go to the first plugin to build. So what we did so far, simply we installed CMake. Let's double check here. CMake exists. We got CMake. We cloned ida-cmake to the SDK folder here. As we can see, we did clone ida-cmake to the folder in the database in the SDK. We exported an environment variable called IDA SDK, and that's all what we have to do. So now we can go to any plugin. So for example, we can go to the SDK inside plugins folder here. Let me show you. So in the IDA SDK, we have all the includes, example of file loaders. These are open source, you can read them. The libs that will be used for to be linked in your plugin, and processor modules, a bunch of processor modules. All of those we can build conveniently. And so here in the plugins folder, there's so many example plugins we can use. I'm going to build the chooser example, this one. So to build this with ida-cmake, I need to have a CMake script. Where do we get a CMake script? We can take a copy of a CMake script from the ida-cmake folder. So in the ida-cmake folder, in addition to having CMake scripts that will be used by CMake, there are your base CMake scripts. So here, for example, We have sample is just for a sample plugin, a single plugin. We can take this CMake file and use it as our base. We have to edit it and adjust the arguments accordingly. So here, let's edit it as such. The project name here, well, we're building a plugin called shoes. So we're gonna change this to shoes. So the project name, the standard, if you're using advanced newer features in the C++ language, you can set the standard level, say C20, for example. The plugin name and the source files. Here we only have a single source file. If you have utils.cpp and util.h and so on and so on, you add all of the source file here. And then the plugin arguments. These are the default arguments just for your convenience. If you're using an IDE and you run, these are the run arguments. By default, ida-cmake will configure ida.exe or ida64.exe or ida on Linux and so on to be the host of your plugin. And these are the arguments to be passed to ida. And then simply the other stuff are ida-cmake specific. So all really what you have to do is simply take a copy of a plugin sample, a CMake script. So we take for a plugin, we take a base CMake script, put it in the folder and update it accordingly. Simply change the project name and the source files. Save that script. Now we're ready to build. So we were working in the plugins folder. So let's go to the plugins folder. Inside the folder was shoes. And here we should see our CMake script. Now, what comes after this is simple. It is basic CMake stuff. If you've used CMake before, that's what will be happening. So the first thing we do is make directory build. That will be building plugins for IDA. And we will make another build directory here, build 64 for IDA 64. So let's build the first one for ida.exe. The first step is after we build the folder, we go to the folder and we configure CMake. So we run CMake, we point it to the folder where the CMake script is. It's just up one level. And for now, just to be 100% sure, we're gonna say use the x64 because IDA is a 64-bit binary in all cases, just to make sure that we're producing 64-bit DLL out of this. And that should be it. So all we have to do is right now is simply run this. It will generate by default on Windows, if I have Visual Studio installed, it will generate a Visual Studio solution, and that's very convenient. So let's run CMake. Now CMake will do everything needed because of the IDA CMake scripts. It will help it. Some stuff that we can observe from IDA CMake in particular. We can observe, for example, this output setting default plugin output file name. And also we can see specific IDA CMake output that it detected this SDK version, for example. And also, where is your development IDA copy? Usually by convention, IDA development copy sits inside the bin folder. And as we'll see in a second, the bin folder is empty in the SDK. And you're supposed to copy IDA installation into the bin folder. So you have a different copy for IDA that is for development than the IDA that you install in your program files that is a stable IDA. So usually, conventionally, plugin development get its own copy of IDA where you might have more development plugins for that specific development environment. So conventionally, when we build the plugin, it will go to the bin folder and then wherever it needs to go. So bin/plugins or bin/loaders and so on. So now all we did is simply run CMake and it generated a solution file. If we look at the folder, what we have here is a solution for Visual Studio. And we can just simply open it. So if we go to Visual Studio, let's see, I can double click. I don't think I have more than one Visual Studio installed. So I'm gonna pick the latest Visual Studio and it opens it. Now, you just have to build. Now, I don't have to use Visual Studio to build. I could continue building from the command prompt, but the idea here is to develop a plugin. So we have to be in some kind of an editor where we can do code editings and running and so on and so on. All right. So this is the source code sample from the SDK. We're not doing anything in particular. If you want to build it from Visual Studio, all you have to do is press Ctrl Shift B, for example, or B, Ctrl B, and it generated the binary inside the bin folder. And since it's a plugin, it goes to the plugins folder. And this is the shoes.dll. Now we're gonna test that plugin. Before we do that, I need to deploy it wherever IDA is. There's so many locations where we can put the plugin so IDA picks it up. If it's sitting here, then IDA should be inside the bin folder. I can copy this, put this in the production IDA and test it, but I want to show you how to take a copy of IDA and put it in the SDK. So wherever you have IDA installed, so let's go to IDA here and take a copy of IDA and let's put it in the bin folder and the SDK. These are like empty folders and some scripts for convenience come with the SDK. And I'm gonna paste the installed IDA. Now that's my development copy. What I can do here now, I can safely clean this up, maybe get rid of so many stuff I don't need. I can safely do that. That will speed up IDA startup and so on. So you can nicely clean up all the things you don't want from this copy. But remember now, what we just built, the shoes, is here. You can also tell from the date, this is just now. So since now I have IDA here, I have IDA exe, and what we set in the CMake script here, the run arguments, we'll notice here how ida-cmake pre-configured those things. So it will automatically detect where ida exe is, and it will pass the same command line arguments. So if you want to test your plugin against a specific database, you can say okay, always run ida with my database, whatever that database is. I'm gonna run ida with -t. -t means open an empty temporary database. So now it's a regular development cycle. So you can use Visual Studio, you can put plugin breakpoints. So let's put a breakpoint here, for example, and just run it. Now IDA will pick up, IDA will be the host. Your plugin will not, none of your breakpoints will hit until IDA actually decides to pick up your plugin. So let's see. Now this is not about how to write plugins, but let me see what did they call that plugin, just to make sure we'll see it here. So here it said called functions, and it's not hidden. Okay, so called functions is what we should see here. So this is our plugin. Now it seems it requires functions, but I don't have any functions in this database. Let's run it. Our breakpoint should hit. So now here we can simply do single stepping, and we should see like a warning message and so on. Hit F5 and let's exit IDA and don't save. All right, so we build choose from the command prompt. Now let me build for ida64 the same story. So going back to the base plugin folder, shoes. Now I go to the build64 folder. I do the same cmake ... to point it to the cmake script. Now the only difference between the the regular build and build64 is we need to specify the -d ea64 equal yes. That's it. This tells IDA that we are gonna be using the ea underscore type to be 64 bits, as opposed to ea underscore t type to be 32 bits. When we do that, we are working in different folders, so we have a completely different solution with the same name, but it's configured to produce the. So let's build it without Visual Studio, as we said. So then to build from CMake, this step here is simply generate a solution. So if I wanted to open Visual Studio, I'm not gonna build it with Visual Studio. It's just gonna show you we have a different solution now. And that solution is the same source file, same everything, but the only real difference is the following here. Because we said EA64, that's how the IDA SDK works. We did pass to the project the EA64 equals 1. If we inspect the previous project, we don't have this. This tells IDA that we are going to generate 64-bit, not 64-bit, all binaries are 64-bit. We're going to generate the bitness of the plugin in IDA terminology, 64-bit plugin. CMake minus build, that's how we build, and that's basically where is our generated build scripts are. So simply CMake build. Now, if you want to generate a specific configuration, let's say the release build, we could say minus minus config release. By default, the config is the debug. So let's just keep it like this and just simply build. Since we generated in the previous step a Visual Studio solution, it's gonna use Visual Studio to build. And now it builds and it emits the plugin to the same location, but just a different suffix here, the 64-bit. That binary will be picked by ida64. So now if you go to ida64 and let's disassemble something just to have a database. And now we should see called plugin. So here plugins, called functions. That's our plugin. Now let me exit and quickly modify the source code. So here, if I simply say, I'm going to change the name of the plugin real quick just to show you how easy it is to modify things. So here, if we go here and let's say change it. If we were in Visual Studio, you would have changed it, press F5, everything will be happening. So let's suppose you grab this plugin, you want to build it, you have the CMake script. I will repeat simply the build command. And same here, since I have two different projects. Now, if I run IDA, I need to run the IDA that has the plugins installed. So I need to run not the installed IDA, but the IDA from the SDK. So now if I run IDA, that will be able to pick up that plugin from the plugin folder. Then we will see our new name for the plugin. So if I now go to the plugins here, and we should see called functions, etc. Now the same story applies for building a processor module. So now going back to the SDK, if we go inside the module, that means processor module. So if you go to module and we pick any processor module, let's say I'm gonna take something that is complete. I think the Z8 is full source code. It should build, and this one, it has so many files. It has a bunch of HPP files and so on. So we really just need the build script for it. Same story. We can take a skeleton build script from ida-cmake. We go to modules. Here we have actually what we have in ida-cmake. We have a nicely set up one for i51, which already is in the SDK. So that will make our life easier for this demonstration. So if I go to i51, it does also have a bunch of files, so it's the same kind of exercise. There's nothing special if I stick with the previous processor module or this one. So let's just take this one and paste it here. I don't think I need to do anything since this CMake script is designed for i51. We can double check that the difference in the skeleton is just how the variable names that we need to set up. So the same project name and then the actual processor module, you only have one, so there's one, and then all the sources. all the CPPs, HPP files, all the sources needed, and simply the rest is boilerplate code. By doing this, I should be able to do the same steps. So we have a CMake script, so we need a build folder. Now, bear in mind the build folder can be anywhere. I don't have to say make directory build and put it here. Build directory could be anywhere. So let's, for example, make the directory in a module. So I call it build. So now I would say cmake dot I51. As long as I tell it where is the cmake script, this build folder will have hard-coded passes pointing to everything it needs to do. So here, same story. Now in that build folder, I do have a solution that I can use. And if I build, it will compile, it will deploy in the proper binary folder. So here, these are the source files, etc. So now I'm gonna build it. Control Shift B, build everything, and it is building. And notice now ida cmake knows where to emit the file. It puts it in the processor's binary directory, and it will be picked up. The final thing I want to show you, we could do the same, by the way, for other subsystems. So if we're gonna build for a file loader, so this is the processor module for a file loader as well. Here we have a simple, even a very simple loader skeleton. It doesn't do anything, but it's a loader skeleton file. You have to put all the logic inside of it. And you can build what IDA has. So if we go to the SDK, in the SDK, we have the processor modules which we have seen, and the LDR, which mean loaders. And IDA SDK ships with complete loaders and partial loaders. Complete loader, for example, pilot should be complete, whereas the PE is not complete, doesn't even have a make file. It's just some header files. That's not the topic of this session. That can be used for you as a plugin developer. But so same as the processor modules, some are buildable, some are not. So you just simply do the same. You take whatever processor file loader you want to build. You go to ida-cmake, to the loader, you grab a template, and the template would look not much different. So it will say loader name, and the same story. You make a build folder, cmake dot dot cmake minus minus build, and you build and deploy. Last thing before we finish this is I did mention we don't have to put the binary output of what we built in the SDK folder. So the SDK, we said it has its own build folder where we have IDA. Now the reason this is because when IDA is built from sources, IDA doesn't really have an SDK from Hexrace's point of view. It's the sources of IDA. And the SDK is just a part of the source of IDA. So that's how the actual IDA project looks like at Hexrace. And that's when they build IDA, IDA UI and so on goes to the bin, and the plugins go to the bin plugins and so on. So we don't have to put plugins here, and you don't have to even go to the whatever you built and cut them. So hey, I'm gonna say cut this, move it, put it, or take a copy and put it in wherever I installed my IDA. Say here, this is where I installed my production IDA, and then paste a copy of shoes.dll here. You don't have to do that. If you want a common plugin, you know it's stable, it's not gonna crash any IDA. Then another good way is to go to app data, and in app data is where you have your application data, and on Windows it's app data. On Linux and so on, you will see in the SDK a README file tells you where they are, like in your home directory in Linux and so on. So app data, Hexrace, IDA Pro, and here if I create a folder called plugins and then paste a copy of that plugin. Now that plugin will be common to any IDA, wherever it is. IDA will go look in that shared folder and pick it up. Same for loader. So if I make here a folder called loader, paste the loader plugin, then it will be picked up from any IDA. Thank you for watching and see you next time.